Guys, Mr. Bowman here. We've got two learning objectives for this video. We're learning to expand special quadratics, and I'll explain what those are in a little bit. And we're also learning to expand quadratics with a coefficient. And again, I'll explain what that is. So the first thing I want us to emphasize, what do I mean by these special quadratics? And there's two types I want us to look at. And the first type is called a perfect square. And the second type, it's called the difference between two squares. So difference between two squares. So we'll get into those two first. Once we've done that, we'll then have a look at this coefficient stuff and what I mean by that. So let's change pen color. Let's get the green pen perhaps. And the first one we're going to look at is the perfect square stuff. And what I mean by a perfect square, for example, x plus 2 squared. So that little 2 up there, that's what I'm looking at, or that's what I'm interested in, these perfect squares. And that little 2 means it's the same bracket twice. So I could rearrange it or change that to look like this. So hopefully you can see what I mean. That little 2, and we've got the same bracket twice. And the reason it's called perfect squares, if you think of this as a shape, well, it would be x plus 2 times x plus 2. So it would look like a square because both the width and the length, or both dimensions, would be the exact same size. When we expand this, the process is pretty similar to the other ones, and the outcomes are going to be the same as well. So we would have x times x, which is x squared, then x times 2, which is 2x, and then down the bottom, another 2x, and then finally, we have a 4. And another feature of perfect squares, you'll find the two x's that sit in the middle of our 4 parts, they're going to be the exact same. It's going to be 2x and 2x, and that makes sense given there's only a 2 in those brackets. We then look to simplify this, x squared plus 4x plus 4. Let's have a look at one more example, maybe a slightly harder one. Let's have a look at 2x plus 1 all squared. And notice there, I did say the word all squared because that entire bracket is being squared. Our first step, I would make it look like a double bracket because I find students who don't do this will make a mistake. They'll end up doing 2x squared plus 1 squared, and then their answer will be wrong. And we'll do that. So we've got 2x times 2x, well, that's going to be 4x squared. And then we've got 2x times 1 plus 2x. 1 times 2x, there's another 2x. And finally, 1 times 1, and there's our final one. And same thing again, those x's in the middle, they are the exact same. And then we've got x squared plus 4x plus 1. I just want to note what not to do. I'm just going to change pen color. Maybe we'll go in red because I don't want you to do that. Let's have a look at another example. X plus 3 squared. This is what not to do. A lot of students, what they're going to do is they're going to do x squared plus 3 squared, which is 9. So x squared plus 9. And this here is completely wrong because you're missing the 3x and the other 3x that you would do if you're expanding a double bracket. So definitely try to avoid doing that. You will make a mistake. Unfortunately, some of us will do that out of impulse, but I just want you to know that's definitely wrong. No maths teacher has ever said to do that, and we must look, like we've done in our examples, to rewrite that as a double bracket and then expand that from there. Okay, so we're going to change pen color again. Let's look for maybe the grey marker. And we're now going to look at this thing called difference between two squares. And the example we're going to look at, a nice easy one, x plus 4, x minus 4. And the key thing I want to note that makes this one unique is the numbers inside. You're always going to have one positive version, and then you're going to have one negative version as well. So they're the two you're always going to come up. So another example could be x plus 3, x minus 3, or it could be 3x plus 5, 3x minus 5. As long as the number portion are the opposites, you're going to be having a difference between two squares. So when we expand this, the reason this is a special one, the simplifying, I think you'll see what's going to happen when I expand this though. X squared, then we've got minus 4x, and then we've got plus 4x, and then we've got minus 16. And if you have a look at the middle, this is again why a special quadratic is special. There's a unique feature. In the first one, they were the exact same. And this time around, we've got minus 4x and positive 4x. They're actually going to cancel each other out. So that's going to become x squared minus 16. So this quadratic is unique because we're going to lose that x portion or that middle portion once we simplify our answer. So let's have a look at a more complicated version. So let's have a look at that one I mentioned before, 3x minus 5, 3x plus 5. And again, see we've got one positive or one negative when we look at the numbers at the end. That's what makes it a difference between two squares. We're then going to go 3x times 3x, 9x squared, 3x times 5, positive 15x, and then you've got negative 5 times 3x, that's minus 15x, and then negative 5 times positive 5, minus 25. And again, that middle portion, have a look. We've got 15x minus 15x. They're going to cancel each other out. So that's going to become minus x squared minus 25. So again, that x portion in the middle, just like before, has disappeared. So guys, that was the first learning objective about special quadratics. What I'm going to do is I'm going to pause the video, and we're then going to get into our second learning objective, and we're going to chat about what happens when there's a coefficient. Our screen has been cleared. We're back for the second learning objective, and that word coefficient is what we're going to be looking at today. And in terms of a definition, it really means there's a number in front of a variable. So if you have a look, 2x, that 2 there would be a coefficient. If you've got 4x squared y cubed, that 4 would be a coefficient. And when we think of brackets, x plus 2 squared, again, that 2 is a coefficient. And at the very end, the type of question we want to look at, that number up front, that 3, makes it a coefficient. And we haven't dealt with any questions that look like this yet. So let's change pen colors, and then let's really rip into a few examples, because this will be an easier one to catch on. So example 1, we're actually going to do that 1 at the end. So we've got 3, which is the coefficient, x plus 1, x plus 4. So when you have a quadratic that looks like this, my suggestion is we deal with this, the coefficient and the first bracket only. And we're going to use our single bracket expanding skills to help us with this portion. So we've got 3 times x is going to be 3x, and then 3 times 1 is going to be 3. So that's the expansion of the coefficient and the first bracket. I then want us to wrap that around in a bracket, and then we're going to put our second bracket, which you'll see over here. That's unchanged. We haven't done anything at all with that bracket yet. Once we've got that expanded first bracket, or that coefficient is now inside the bracket, we can just go ahead and expand like we would normally. So we've got 3x squared times 3, so that's going to be 3x squared. And then we've got 12x, then we've got a 3x, and then we've got a 12. And as always, have a look at the middle, see what you got. Make sure you simplify those. We've got 3x squared plus 15x plus 12. So fairly straightforward, I think. We're just using our single bracket expanding to finish it off. So let's have a look at the second one as well. We'll try to make this one more complicated. Let's say we've got 4a, so 4a, and then we've got maybe a plus 4, and then we're going to have 2a minus 5. So it looks like a bit of a nightmare, but let's have a go. Let's see what happens when we do this. So same step, focus on coefficient, which can include a letter, nothing wrong with that, and the first bracket. So we've got this times this, 4a squared, this times this, plus 16a. And we're then going to wrap that around in a bracket. We're then going to go ahead and carry on. We've got 4a squared times 2a, that's going to be 8a cubed. We've then got 4a squared minus 5, which is minus 20a squared. And then we've got 16a times 2a, that's going to be plus 16a squared. And then finally, 16a times negative 5, and that's going to be negative 80a. Hopefully I've done my maths right there. Numbers were getting pretty big. We're then going to look to group the middle, even though it's not just like an x or an a. It's a squared, but the middle should always be the same. We're going to group them together. So it's going to be 8a cubed minus 4a squared minus 20 or minus 80a. So guys, hopefully you found this video useful. We've looked at 3 different things. We hopefully should say we can expand perfect squares. Just raining as I'm finishing the video. Hopefully it doesn't drown me out too much. So perfect squares, difference between 2 squares, and expanding quadratics with coefficients. Thanks so much for watching, guys. Make sure you get all the notes down. Make sure you get all your examples down. Make sure you get into heaps and heaps of practice.